Hi everyone, welcome to Mihitha Academy. As part of today's episode, we'll understand binary number systems. So, you might have heard this binary number system at most of the places because in current era, most of us will be using digital gadgets in our house. It can be laptop, it can be desktop, it can be your smartphone, or it can be your tablet, or it can be your MP3 player, or it can be even your set-top box of your TV. In all those electronic devices, there will be an integrated circuit, IC, we call it as. IC chip would be there. That chip is made up of transistor. Okay, so the chip what we call as it has billions of transistors. Okay, so as part of today's episode, let us understand the overview about the binary number system, what is the importance of it. At the same time, we'll also see how can we convert the decimal numbers to equivalent binary numbers. At the same time, we'll also see how can, if we have a binary number, how can we convert that into equivalent decimal numbers. We'll see the procedure in details. Come on friends, let us do deep dive in binary number systems and start the session. So coming to the overview of binary number system. As I said earlier, the binary number system, right? These integrated circuits in a computer are made up of many transistors. Okay, transistors are like a individual small circuitry present in an integrated circuit. But every single IC chip will have millions or billions of transistors. Okay, so the transistor can be activated by an electrical signal. So the small electrical circuitry called transistor, right, that can be activated by passing an electrical signal. Either you can pass low signal or high signal. So low we can call it as off, high we can call it as on. Okay, so these transistors can be activated using electrical signal. It is like you are giving energy or not giving energy. So the above states can be represented using digit 0 digitally, 0 for low, 1 for high. Okay, on state. These 0 or 1, see, if you see, there are only two numbers, 0 or 1. That's the reason binary. Okay, we call that number system called binary number system. In the binary number system, we can represent anything either using 0 or 1. Okay, that's the only funda. So binary number system also called as base 2 system, because we have only two numbers, we call this as base 2 system. Binary numbers can be mapped to decimal numbers which are base 10, that can be understood by human being. Generally, if you see, we generally, any common transactions which you do over your phone pay, Google pay, or when you go to shop, you will pay the money, right? Generally there we will use 10 rupees, 100 rupees. The base what we use as base as a 10. Okay, binary number system we'll use base as 2. So this particular chart or table will show you the decimal numbers and equivalent, the decimal numbers and equivalent binary numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the decimal numbers if we have to represent, or what are the equivalent binary number if we have to see. 0's equivalent binary number is 0. 1's equivalent number is 1. 2 in decimal number system will be represented in the binary number system will represent as 1 0. Decimal number 3 will be represented in binary number system as 1 1. Similarly for 4 1 0 0, for 5 1 0 0 1 6 1 1 0, 7 1 1 1, 8 1 0 0 0, 9 1 0 0 1. You don't have to get confused or mug up. Just have a look at this table. But in our current session only, you will understand how this decimal number has been converted into binary numbers, or why. For example, the number 7 here, right? It is 7, whereas in binary number system 1, we will understand that. Okay, in a while. So far what we have understood, guys, we have understood what exactly is a binary number system and base 2 system we call it also has, right? Now let us understand how can we convert, or conversion of a decimal number to a equivalent binary numbers. Assume that there is a decimal number given in your exam or there's a number in front of you, you have to convert that into binary numbers manually. How can you do that? Let us understand that. Okay. So these are the steps to be followed to convert any given decimal number to a binary number. There are 4 simple steps: step 1, step 2, step 3, and step 4. Let us understand each in detail. So step 1, assume that there is a number given to you. You have to divide that given number by base value of a number system which is to be converted. So in case of binary number system, you want to convert it to binary number, then the base value will be 2. So you have to divide a given number by 2 repetitively. Okay. Once you divide it, you have to note down the remainder, step 2. Then keep on dividing the quotient by the base value. In case of binary number system 2, note the remainder till you get a quotient 0. So you have to keep repeating this step. Divide by 2 and note down a remainder, and then if the quotient is non-zero, you have to repeat the division process and note down the remainder. Then once you get a quotient as 0, what you have to do? Write down the remainders in the reverse order from the bottom to top. If you can able to do that, you will get a equivalent binary number for a given decimal number. So let us go and understand one example. This is one of the example given in your NCERT book or even your CBSE or ICSE book. So let us take that as an example. Then we will take an exercises. Okay. So convert a decimal number 65 into equivalent binary number. Step 1 is what? Divide a decimal number by 2. So they have 65 over here. See, they have 65. I am trying to divide 65 by 2. 2, 6, let us take the highest digit. 2 3s are 6 and 2 2s are 4. Remainder is 1. Then again, the quotient is not 0, correct? Quotient has to be 0. You have to stop this process. Then, so since the quotient is not 0, let us repeat the process. 2 1s are 2, 2 6s are 12. Quotient is 0. Now again, divide 16 by 2. 2 8s are 16. Quotient remainder is 0. 2 4s are 8. Remainder is 0. Then divide 4 by 2. 2 2s are 4. Remainder is 0. 2 1s are 2. Remainder is 0. Then 1 is left here, but you have to also still continue the process one more time, because you can stop only when you get the quotient as 0, correct? 2, you are going to divide this guy. 2, you are going to divide, right? 2 1s are 2, but this 1 is less than 2, correct? So the quotient is 0, remainder I noted down as 1. So now collect all the remainders from the bottom to top and get the binary equivalent. So I have to write this as 1 0 0 1 0 0, 3 more zeros followed by 1. This is the equivalent binary number. So whenever you are representing binary number or decimal number in general, whenever you are working on this decimal or binary or any other number system, right, always try to put that base value. Here we have kept it as 2. Clear? Hopefully with this example you understood what is the steps to be followed. So now let us take some exercises. So convert a decimal number 593 into a binary number. So now what we have to do, we have to repeat that steps. So given decimal number is what? The given decimal number is 593. Now what I will have to do, guys? I have to divide this by 2. Here I will note down my remainder. So 2 2s are 4, 2 9s are 18, and then 13 is left. 2 6 are 13, remainder is 1, correct, guys? And then again 296. Take 2. Since the quotient is not 0, repeat that division by 2 process. 2 1s are 2, 2 4s are 8, 2 8s are 16. Remainder is 0 since it's an even number. Again 2 7s are 14 and 2 4s are 8. Remainder is 0. Since the quotient is not 0, repeat the process. 2 3s are 6, 2 7s are 14. Remainder is 0. Now since it's an odd number, the next step there has to be one remainder. So now repeat the steps. 2 1s are 2, 2 8s are 16. Remainder is 1. Correct? Because it was 17 was left. I cannot divide 17 in whole. So 2 8 is 16, 1 is remainder. Now repeat the process. Since the quotient is not 0, the current quotient is 8. 2 9s are 18, quotient is 0. Then repeat the process again. 2 4s are 8, remainder is 1. Repeat the process. 2 2s are 4, remainder is 0. Repeat the process. 2 1s are 2, remainder is 0. Since 1 is there, 2 quotient is 0 because I cannot divide 2 in 1. 1 is less than 2, so the remainder I will write it as 1. So you have to now write the value in reverse order. Okay, 1 0 0 1 1 0 1 0 0 1, then 0. This is done. Now 1, I have written this. Now 3 zeros followed by 1. 0 0 0 1. This is the binary equivalent of 593. So in our example, you see the example, they have given 593 as a decimal number. We have converted successfully to equivalent binary number. Clear, guys? So let us see one more example. So we have 326, the second exercise. We have to convert 326 into a equivalent decimal number. So if you want to pause the video, you can pause the video and try yourself. After that, you can come back and resume the video to verify your answers also. So, however, let us see 326. The procedure remains same. If you want to convert a given decimal number to a binary number, you have to divide by 2 because base is 2, correct? And you can note down the remainder. So 2 1s are 2 and 12 is left. 2 6s are 12 and 2 3s are 6. And what is the remainder? 0. Correct. So similarly, quotient is non-zero. The current quotient is 163. Repeat the process. 2 8s are 16 and 2 1s are 2. Remainder is 1. So now 81 is left. The quotient which is non-zero. Repeat the process. 2 4s are 8. 0. Remainder is 1 because we cannot divide 2 by 1. 1 is less than 2. So now 2 2s are 4. Write 0. The remainder is 0. 2 1s are 2. Remainder is 0. The quotient is 10, so you have to repeat the process. 2 5s are 10. Remainder is 0. Now divide 5 by 2 again. 2 2s are 4. Remainder is 1. Now 2 1s are 2. Remainder is 0. Now one more. 2 0. You have to write it 1. So now if you see the example what we have right now is we have to write an answer in reverse, the remainder in reverse order to get it. 101, I am writing from here. 101 000, I will write 000 110 110. This is the binary equivalent of 326 decimal number. This is the decimal number given and we have converted into equivalent binary number. Clear, guys? So let us see one more example. Convert decimal number 79 into a binary number. So write down the same process. 79 divided by 2, record the remainder. 2 3s are 6, 2 9s are 18, remainder is 1. Since the quotient is non-zero, repeat the process. Division of by 2. 2 1s are 2, 2 9s are, remainder is 1. 2, you cannot divide by 1. 2 9s are 18, remainder is 1. Then repeat the process. 2 4s are 8, remainder is 1. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is 0. 2 0 times, but the remainder is 1. Now we have to remain this. We have to write the remainder in a reverse order starting from bottom. 1 0 0 1 1 1 1. So this is the binary equivalent of decimal number 79. Clear guys? Hopefully you guys have understood how can we convert a given decimal number into a binary number. So let us apply the same principle what we have just now learnt backwards. So initially when we started this session we have seen this table, right? Decimal number and equivalent binary number. So let us apply the same process for number 5. So take number 5. How we got the equivalent binary number? Start dividing by 2 and record the remainder. 2 2s are 4, remainder is 1, correct? Then 2 1s are 2, remainder is 0. You have to repeat the process till your quotient becomes 0, right? You cannot, 1 is less than 2, so quotient is 0 and remainder is 1. So you have to write the number or remainder in the reverse order to get a binary number. 101 is the binary equivalent of the number 5. Okay, the principle holds good. Okay, let us try for one more example. Maybe for number, let us take a bigger number. Which one we will take? Let us take 9. Okay, so take an example of 9. Try to divide this guy by 2. Record the remainder. 2 4s are 8. Remainder is 1. Then since the quotient is not 0, repeat the process. 2 2s are 4. Remainder is 0. Then 2 1s are 2. Remainder is 0. So now since the quotient is not 0, repeat the process. 1 is less than 2. Quotient would be 0 and 1. You have to record the remainder in reverse order to get a binary equivalent. So 1001 is the binary equivalent of number 9, which is exactly matching. Got it guys? So this is how you can convert a given decimal number to binary numbers. Great. So far we have learned what exactly is a binary numbers, how can we convert a given decimal number to a equivalent numbers in a binary number systems. Correct. Now let us see the other way around, meaning assume that there's a binary number given to you. Okay, let us understand how can we convert a given binary number to a equivalent decimal number. Okay, very simple process. Again, let us understand this in detail. These are very important even in your board exam. Even the people who are writing competitive exam like bank exams such as IBPS, or even competitive exam like state board exams or state commission exams like KPSC, UPSC, even the central exams like UPSC, all those things, these are very important. Okay, so let us see the steps. Conversion from other number system to a decimal number system. In our case, the number system what we are concentrating on is the binary. We are trying to convert a number from binary number system to a decimal in number system. Let us see these 4 steps in detail. So the step 1, if you see the step 1, write a position of a number for each alphabetic symbol, alphanumeric symbol in the given number. Okay, first we have to write a position number. Then get the positional value for each of the symbol by raising its position to the base value. Base value in case of binary number system is 2. Multiply each digit with the respective positional value to get the decimal value. Then you have to add all these decimal values what you got in step 3 to get a equivalent decimal number. Don't worry about the steps. Just go through, pause the video and try reading this. Once you understand the actual hands-on or the actual way of solving these steps or implementing these steps, you will easily correlate. Let us move on. So this is a given example, one of the example given in your NCERT board book. So convert 1101, which is base 2, which is nothing but binary number, to a equivalent decimal number. So now write down the digit. Digit is nothing but the given number 1101, which is exactly this. Now we have to write the positional value, the second step. The positional value actually starts with 0. Always start numbering from 0 from your right digit. Okay, 0 1 2 3. The next is we have to find out the positional value. How can you find out the positional value? Since the base is 2, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. This is the positional value. But now, in order to get a decimal equivalent, what we will have to do, guys? I have to multiply the given digit with the positional value. So 1 into 2 cube plus, okay, then 1 into 2 square plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 0. Now I have to solve this smaller expression. So 2 to the power of 0 is what? 1. 1 into 1, it became 1 plus, okay, this one. Then 2 to the power of 1 is 2, but 2 multiplied by 0 is 0. Then again plus, right? Then 2 square is 4, 4 into 1, 1. We have written 4 here. Plus, then 2 cube is 8, 8 into 1 is 8. So now we have to sum 8 plus 4 plus 1, 8 plus 4 is 12, plus 1, 13, base 10. So this is how you convert. The given value is 1101 base 2. The equivalent binary decimal value is 13, which is 13. Okay. So let us apply the similar principle and try to find out the value for a given number. So 112. Okay. So now you can write down the digit 111. Correct. Then the position value you can write position, which is 0, 1, 2. Now position value. So you have to raise 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Then the decimal equivalent value would be, you have to multiply the digit with the positional value. 1 into 2 to the power of 0 plus 1 into this 1 into 2 to the power of 1. 1 into 2 to the power of 1 plus 1 into 2 to the power of 2, which is nothing but what? 1 into 2 to the power of 0 is 1 plus 1 into 2 to the power of 2, 2 to the power of 1 is 2 plus 1 into 2 square is 4. So now 4 plus 2 plus 1, the final value is 7, which is base 10. So 111 in binary is equivalent to 7. Number 7 in decimal number system. Clear, guys? Very simple. The next, convert given number into a decimal number. It seems very big number, but don't worry. You apply the same process, but if you have to fast forward the steps, all you have to do is start from the very rightmost digit, 1 into 2 to the power of 0 plus 0 into 2 to the power of 1, correct? Plus, I am writing the third digit from the right side, 1 into 2 to the power of 2. This digit is done. Plus 0 into 2 to the power of 3 plus 1 into 2 to the power of 4 plus 1 into 2 to the power of 5. This is this, this is this, this is equivalent to this, this is equivalent to this, this is equivalent to this guy, and the last digit is equivalent to this guy. Now you just solve this expression from the right. 1 into 2 to the power of 0 is 1, 0 into 2, 1 into 2 square is 4 plus 0 into 2 cube is 8 plus 1 into 2 to the power of 4 is 16 plus this is 16, 1 into 2 to the power of 5 is 32, is equal to 32 plus 16 plus 0 plus this would be 4 plus 0 plus 1. 4 plus 16 plus 4 is 20. 20 plus 32, 52 plus 1, 53. 53 is the answer in base 10. Clear, guys? So let us apply the similar principle to our table what we have seen. Let us take any binary example and convert into equivalent decimal number. Okay, let us take an example of this guy, 100 base 2, correct? So 100 which is in base 2 will have to convert into base 10. How can we do that? 001, the position digits, correct? Then position is what? 0 1 2. Position value in number system is what? 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Now we'll have to find out the decimal equivalent. So to get the decimal equivalent, you have to multiply the digit with this value. 0 into 2 to the power of 0 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 2, which is 1 into 4 plus 0 into 2 plus 0 into 1, which is 4 plus 0 plus 0, which is equal to 4 in 10. Clear? Which is exactly matching. So hopefully as part of this video you understood what exactly is a number system, how can you convert a given decimal number to a equivalent binary number. At the same time you also understood and saw the steps to convert given binary number to a equivalent decimal number. Hope you like this video. To support us and our effort, you can scan this QR code and make a donation. Thank you. Hopefully you like this video, guys. If you like this video, please do subscribe to our YouTube channel and share this video information with your friends and family members or somebody who is really interested in learning the concept in detail. Also, please do comment in the comment section of this video that on which topic you are expecting me to do the video in the coming days. Thank you so much, guys. Stay tuned to our YouTube channel. Have a good one. Bye bye.